Hi, everyone. Welcome. And thank you so much for taking the time to join us for today's webinar, Yara Rules. My name is Ryann Hallback, and I am a Principal Intelligence Analyst here at the Vertex Project. And I'm joined here by my teammate, Mary Beth Lee. Today, we're going to talk to you about Yara Grid, a Synapse power-up that facilitates collaborative malware hunting and detection at scale. For this webinar, we'll give you a brief overview of Synapse, discuss how Yara is used for threat intelligence, go over some common Yara deployment scenarios and some challenges associated with those scenarios, cover our solution to those challenges, and then we'll end by giving you a demo of Yara Grid using the December 2020 FireEye Red Team tool compromise as a case study. So first, what is Synapse? At Vertex, we wanted to create a system that would allow us as analysts to perform every stage of the intelligence lifecycle in a single system. So we wanted to plan our research, do data collection and processing, perform analysis, and create reports in a single system. Our team wanted the ability to collaborate and represent data from any domain, not just the threat intelligence space. And we wanted to be able to interact with that data and easily ask questions and get answers and capture our analysis and assessments in a single system. So we created Synapse, a system that combines a hypergraph technology, a data and analytical model, and a custom query language with services that facilitate things like data ingestion and enrichment, analysis, and automation. So we like to say that Synapse uses data, platforms, and teams and allows us to collaborate and perform cross-domain analysis. One of the core aspects of Synapse is what we refer to as power-ups. Power-ups are custom connectors or integrations that extend Synapse's base functionality. So they're designed to help us as analysts and empower analysts by augmenting our workflows, our data analysis workflows, like ingesting data from VirusTotal or parsing a spear phishing email. One of the power-ups that we integrated into Synapse to help facilitate threat hunting and detection at scale is Yara Grid. Yara Grid is a Yara management service that allows you to invoke Yara, manage rules, and matches all from within a single interface. So why did we choose to integrate Yara into Synapse? First, what is Yara for those of you who may not be aware? Yara is an open source malware analysis tool used by malware researchers, defenders, and analysts, and more, really, to help us detect and categorize malware. It can be used to detect the presence of malicious code in static files and in memory. It's intuitive, it's effective at analyzing code, and because of those reasons, it's become one of the de facto tools used by researchers and security vendors. So that means that I commonly use it as a part of my workflow. Although Yara is effective, I've come across several challenges when I've tried to use Yara in a production environment. So in the past, if I needed to use Yara, it could be locally, where the Yara rules, the malware, the execution of Yara all happened locally, which meant that my results were stored locally as well. Or sometimes I've used Yara on an internal server or an appliance like FireEye's AX malware analysis appliance, or using a third-party vendor like VirusTotal. In those deployments, everything is remote: the rules, the malware, Yara execution, and the results. All of these implementations made it difficult for me. It made it difficult for me to collaborate with my team, to scale my analysis and access Yara rules and malware that was located in different places. And it made it difficult for me just to determine what my organization's current detection posture was as it related to a piece of malware or a malware family. Scaling was a challenge because what I was finding was that the speed of my research would sometimes outpace the speed of my analysis. This was especially true during active IR investigations where I needed to move quickly. So for local deployments, my analysis speed was constrained by the processing power of my system. And then my test bed was limited by my local storage size. For remote deployments, analysis could just be slow. And this was because sometimes static analysis was often coupled with dynamic analysis. Sure, the malware repos were bigger, but because malware took a long time to analyze, or because of service agreements imparted by third-party vendors, I can only analyze a certain number of files a day. Collaboration was also a challenge for me. Within my organizations, I would have several teams that would use Yara. We had SOC analysts, we had the IR team, malware analysts as well. Teams would be able to maybe share rules internal to their team, but when it came time to share rules and malware across teams, we just couldn't. So that meant that effective collaboration just didn't exist. When you can't collaborate, then teams can't share rules, malware, or results. This leads to a duplication of effort where you have multiple people writing different rules to detect the same malware. And then collectively, all of these challenges presented an even bigger challenge for me analytically because I wanted to leverage the Yara match results for my analysis. So if I had a malware appliance referring to a malware sample as pillow mint, I wanted to capture that in my analysis and use it to inform my follow-on research. What I realized was that Yara had become such an integral part of my workflow, but it was still one aspect of my workflow that I constantly found myself going outside of my analysis platform to use. So we created Yara Grid. Yara Grid is a Yara service that's integrated directly into Synapse. It allows you to simply manage your Yara rules and match results in a single system. It allows you to run Yara rules over a large malware corpus. You can create rules easily as well because you can easily create individual rules or perform bulk ingestion from external data sources. You can also leverage Synapse's underlying functionality to help with automation and automate your rule execution and even apply context to match results. All of this allows you to incorporate your Yara match results into your threat analysis, which is just something that we couldn't find with any other system. There are several benefits to using Yara Grid. It's integrated. So this means that we have streamlined workflows and there's no more context switching. Being able to fuse Yara rules and match results with different data like host execution data or DNSA records facilitates pivots in research and allows you to perform holistic analysis. It also provides centralized access to rules and the samples. And because everything is centralized, now you have increased sharing and visibility, which eliminates duplication of effort. You also have the ability to collaborate and co-author rules if you would like, or get feedback on a rule that you have written. Yara Grid is also fast, and it supports a large number of files, which makes it scalable. And it's on premises, so you can control your test bed, and that allows you to be able to scan file samples that maybe you couldn't upload to third-party servers due to data sharing agreements. So one question we would commonly get about Yara Grid is, hey, how well does it perform, especially in comparison to just running Yara locally or running Yara that's embedded in a malware analysis appliance? To answer this question, we came up with our own unit of measurement that would allow us to evaluate the speed and the scale of Yara deployments. So introducing Yara operations per second, or YOPS. This is the speed at which a set of production rules can evaluate a set of malware samples. So how did we do? We took about 23,000 malware samples and we evaluated them against about 1,700 Yara rules. In about 6.5 minutes, we were able to process 24 gigabytes of data, malware specifically. And in the end, we had about 5,000 files that were matched by 47 rules. This means that our Yara Grid instance is able to perform about 103,000 YOPS, or Yara operations per second. This is actually pretty fast, especially given that some malware appliances can only operate on about 10,000 files a day due to the expensive nature of the execution environment. So obviously YOPS will be dependent upon the number of workers that you allocate. But what this does do is give you an idea of the throughput that you could expect if you had Yara Grid deployed in your environment. So now that I've given you a brief overview of Synapse and Yara Grid, I'm going to pass it over to MB, who's going to demo Yara Grid using a case study.
Okay, So back in December 2020, FireEye announced that there had been unauthorized access to the red team tools. And in response, they've released indicators and Yara rules to assist the community with detection. So for this demo, we're going to pretend that we want to ingest these rules, which live on their GitHub page here, and use them to perform a retro hunt through our environment to try and detect related malicious activity. This will showcase a couple of different Synapse features, including the ability to create a forked view for testing, the ability to bulk ingest Yara rules from a remote source, and the ability to create and manage rules using Yara Grid. So the first thing that we're going to do is go over and fork a view. So we're going to fork off of the base layer. I'm just going to name it MB so that I remember where we are. And creating a forked view is helpful because it basically takes it creates your own scratch space. It basically takes all of a copy of the nodes and annotations that are on the underlying base layer and creates a space where anything that you add to those nodes or any nodes that you add, any changes that you make, nodes, tags, annotations will stay contained within your forked view. They won't affect the default layer. And later, if you decide that you're okay with those changes, you can go ahead and merge those down to the base layer. Otherwise, you can go ahead and just get rid of your fork and it won't affect anything on the base layer. So you really have your own kind of sandbox to work with. So what we're going to do is we're going to use a tool called the file parser. And we're going to use that to go out and grab the Yara rules that FireEye published on their GitHub page. We're going to download those as a single file bytes node, but then the parser is going to break those out into individual Yara rule nodes. And we're going to tag them with two things. The first tag is going to be our VTX story tag. We're just calling everything VTX story redtree.core, just as a way to organize the nodes that we're working with. And then we're going to also add a pub.FireEye tag just to show that these Yara rules are something that FireEye published in December 8th, 2020. So let's go ahead and run this. And because we're doing a bulk ingest, we're going to be within the research tool on Synapse. There is another tool that we can use, which we'll go ahead and use later. I'll give you a little preview right now. We go over to the modules on the side and we select Yara. We also have this interface where you can search things by name. You can also add individual rules, and you can go in and pretty easily edit rules and then update versions. And we'll come back to this one later, but because we're using, because we're working with all 169 rules that FireEye published, we're just going to be in the research tool because it will let us perform bulk actions a little bit more easily. So now that we've ingested our rules, we have them showing by the name property, and we also have their text. We have two other properties that we haven't filled out yet, author and enabled, but we'll go ahead and do that later. So now we want to take our rules and we want to pipe them to the Yara validate command. And the validate command is just going to perform a syntax check and just make sure that there's no syntactical errors, but it looks like there's none. If there had been, we would get some red text showing an error right below our storm query bar, and then we'd also get a little red flag over in the console telling us that there's a problem. But these all passed. So the next thing that we're going to do now that we validate them is we want to do some testing. And we want to make sure that these rules are able to detect the files that they're supposed to detect. If they don't work, we don't want them. We also want to make sure that they're not throwing a bunch of false positives. And we want to make sure that they're properly scoped. We want them to detect what they're written to detect, but not detect everything that's out there. If they're too noisy, we don't want to deploy them in our production environment. They're not going to be too useful for us. So the first thing that we're going to do is test for true positives. And we're going to take advantage of something that FireEye did when they were writing the rules. If you go and we lift one of the rules here, we can see that FireEye listed in MD5 that the rule is for the file that the rule is based off of. So what we're going to do is go and scrape out all of the MD5s that are included in the text property of the rules, and we're going to apply a VTX story.redtree.core tag to those. And applying this tag to this hash is actually going to trigger some automation that we have running in the background. When we apply a VTX story tag to a file hash, it is going to launch one of our power-up services. In this case, it's going to call to our VirusTotal power-up and go and download everything that VirusTotal knows about that file, including the file bytes. So in this case, it's useful for us because we want to use the file bytes to run those files against the Yara rules. Let's see how many we actually got back. And it looks like VirusTotal found bytes for 12 of those files. So now that we have those file bytes, we'll go and we'll run them against our FireEye rules and grab my query. So with our query here, we're lifting the file bytes from those MD5s that we scraped, and we're going to pipe them to the Yara match service. We're using tac yield so that it will show us any resulting matches. And then we're using the tac rules tag to specify that we only want to run these files against the rules that have been tagged with VTX story red tree core. So we'll go ahead and we'll run that. And we got back 17 matches. And I just want to show you what the Yara match nodes look like quickly. They show the file, the hash of the file that matched on the rule, and then they also show the specific version. In this case, when I ingested the FireEye rules, I didn't set any version number, so it just says version 0. But this combination of information can be helpful if you want to, if you're reversioning rules and you end up like updating, like say I went in and I fixed a rule and updated it to version 1, the match nodes would kind of serve as a type of detection history and show what file matched against which rule and what specific version of that rule. So now that we've gone and we've run these, we're going to go and pivot to the file, to the Yara rules that were involved in these matches. And we're going to add a tag that shows that they're VTX story redtree.core.match. And so we're adding this to show that these were the rules that we had the file bytes to verify that they were able to detect what they're written to detect. The other rules we're going to keep, just maybe VirusTotal will end up eventually getting those file byte nodes and we'll be able to verify them. But for now, these are just the ones that we're going to move forward with the rest of our testing and for possible deployment. So let's just lift our rules there by tag. The next thing that we're going to do is we're going to test for false positives. To do this, we're just going to use NSRL files as kind of a stand-in for files that these rules shouldn't be detecting. We're going to limit it to just 100 of those NSRL files, and we're going to pipe them to the Yara match service, again, specifying that we specifically want to run it against our story tag, and then using tac yield so that will show us any results. And looks like we didn't get any false positives from that. So then the last thing that we're going to do is just check the scope. And for this, we're going to basically run kind of the same query, but we're going to change the files that we're using. These are going to run against files that we've tagged with vtx.testbed.yara. And the testbed.yara tag is just to simplify it. These are basically like a grab bag of malware that we have in our Axon, just to see how noisy this is. And it looks like we didn't get any hits from that. So these seem to be pretty well scoped, which is good for us. So before we go and we merge these down into our production layer, we're going to do a little bit of housekeeping. We're just going to lift our Yara rules and we're going to apply 2 tags. Or sorry, we're going to apply 1 tag. The first is detect.prod, and then the other one is just going to be changing that enabled property that I pointed out earlier to true. And we'll go ahead and run that, and we can see the enabled property. And then the last bit of housekeeping that we're going to do is to take all of the FireEye Yara rules that we ingested, and we're going to apply the author property. The author property, actually, if you pivot off of that, it goes to a PS contact node. And in this case, the PS contact node is for FireEye's GitHub page. And this is just to show us where these rules came from in case later we have any question about it. And also, it's another property that we can use if we want to filter or lift or things like that. So now we're ready to go ahead and move these down to our production layer. One of the things that I tend to do before merging a view into a production layer is to run a command that's merge tac-tac-diff. And what this does is it shows me all of the changes that I made within my view. I'll usually go over to the scroll to form and just kind of eyeball it and see if there's anything that I don't recognize, but there are 169 Yara rules. One of the things that I'll specifically check is usually the syn tag, just in case I created a tag that I was using for testing that I don't want to move down into the base layer, like mb.cookie or something like that, that I don't want somebody else to find because that would be embarrassing. But here I recognize everything that we have, so we're okay to move down. So what we want to do is just click on the downward arrow, and that will give us a pop-up, say, do you want to move to default? You can say confirm. Alternatively, if we didn't want to deal with that, if we were testing something and it didn't work out and we didn't want to save the changes, we can just click on the little trash can over here, and that will discard our view. For this, since we already merged everything earlier to production view, we'll just switch over to that view. And this is our Yara rules view. So now that we have our FireEye rules in our production layer, what we want to do is go ahead and use them to run a retro hunt over all of our assets that we have modeled in Synapse and see if there's any related malicious activity that we match on. So this query it's going to lift all of the Vertex hosts that we have. It's going to pivot to the files that are modeled to those hosts and then take the specific bytes of those files, pipe them to the Yara match service and run them against the file or run them against the Yara rules that we've tagged with our red tree core.match tag. And then we're using the tac yield so it should spit out any results. And it looks like we have 2 results. So it's actually the same file that hit on 2 different rules. So we can go highlight those both and click the explore button to see what's going on. So these are the 2 rules that they hit on. If we have questions about which each of those rules contained, we can either double click on the text and it will get a pop-up, or we can just hover like we're doing now, and it will also show us like what that rule contains. We can also go and look at the file byte of that file that hit on that rule. Let's click explore. And so you scroll to form to see if we can find out a little bit more. There's our Yara match nodes showing the 2 matches that we just saw. We can go to AV file hit, and this is all data from our VT power up. So it looks like 66 of the AV engines that VT uses detected this as malicious. So it's probably not a great file that we want on our system. One of the names that's popping out is Cobalt. So maybe it's Cobalt Strike, maybe it's just related to that. Who knows? Either way, we're not really thrilled with having this. So we've now moved to an active investigation for the host that this file was found on. And we went ahead and pulled the other files that appeared on this host around the same time. And it looks like there's one other file that showed up like a week or so before. So we'll go ahead and take a look at that. And we'll pivot. There's the host that it was on. And there's the file itself. And one thing I want to point out about this file is that it has a CSERT tag on it. So we applied the CSERT tag when we started doing investigation into this host. We applied it to the tag or to the files that were on here. And applying the CSERT tag to a file byte node kicked off some automation that we have. This automation, in this case, did 2 things. The first one was that it went and it reached out to our VirusTotal PowerUp service, and it went and pulled in everything that VirusTotal knows about this file. It also went and ran this file against all of the rules that we have in our production. So all of the Yara rules. So let's go see what we know about it. Can go back to scroll to form. And we can tell that the VirusTotal PowerUp ran because we have some execution data. Like there's this inet DNS request. And it looks like VirusTotal saw it reaching out to this domain. We can go pivot on that and click on that domain. And so it looks like this domain was something that we modeled previously, probably through OSINT. It was published by the US Cybersecurity and Infrastructure Security Agency. And it looks like they thought it was related to malware that they're calling Softful Media. So the fact that we have a file that reaches out to that domain is on one of our hosts is not great. Let's go back to look at that file. Scroll to form. And what I'm looking for here that I don't see is a match node showing, since we know that the automation ran it against our Yara rules that we have in production. What I would like to see is that we have a Yara match node saying that like, hey, it matched on the rule that detected it. But we don't have one. So it looks like we have a gap in our Yara detection. So we're going to want to go ahead and address that. So we'll go and we'll just fork the view here so that we can have some place that we can test, and we'll just call it MV2. And since we're only going to create one rule for this, we're going to go over to the modules and we'll add a new rule, and we'll just call it MV test because I'm being very creative today. And I'm going to copy and paste in a rule. And one of the things to note about Yara Grid is that it supports versioning. So it allows for the ability to quickly change rules and then track iterations of those rules as you go on and refine it. So let's say that I wrote a really crappy first rule and I forgot to specify any of the strings. We can go ahead and we can validate it, and it will pass validation because it's syntactically valid. There's no errors here. So I save it, and then I update it because this is the first version of the rule, and I just say version 1. So there's our rule. And then I go over and I try to test it. So the first test that I'm going to do is just to see if it detects that file that we are missing detection for. So in this command, I'm taking that file byte node and I'm running it to the Yara match service. And then I'm specifically running against the rule that I named MB test. And I'm using tac yield to spit out results. And it looks like it does detect that rule or that file. So that's good. So then I go and I test for false positives. And I'm using basically the same query, except I'm running the NSRL files against it. And so running this, we can see that we detect a lot of things that we don't want to detect. So go back over to the module, look at our rule. Oh, I didn't specify any strings. We'll go and we'll fix that. We'll say, hey, you have to detect at least 2 out of 3 of these strings. I'll update the version so that it's version 2. And then I'll save the rule. Then we can go back and test again. And for the sake of time, we'll just do all of our testing in one query. So I'm going to test against the, let's show you. I'll test against the VTX testbed, which is the grab bag of known bad of the malware from our Axon. I'll test against the NSRL files, and then I'll test specifically against that one file that we want to detect. I'm piping all of those to the Yara match service and specifying that I want to run it against the MB test rule, and I'm using tac yield so that it will spit out any of the results. And we'll run that and see what we get. And it looks like we only have one match, and it's the file that we wanted to detect. So at this point, our rule passed passed all of our testing. In this case, I might want to do a little bit of tidying up just because the first iteration of that rule was so bad. I don't want to keep those match nodes. So I'm going to go and delete all of the match nodes specifically for that first version of the rule. They're not something that is worth moving down to the base layer just because that rule was so bad. So we'll go ahead and delete those. Then I'm going to do a little bit of housekeeping before I merge this rule down to production. I'm going to lift it by name. I'm going to add the cnode-detect.prod tag, and then I'm going to set the enabled property to true. I'll go ahead and do that. And then at this point, I'll go ahead and I'd merge down so we can merge back into our Yara rule. Go ahead and confirm. And so now we're in that production layer view, and it went ahead and it deleted the other view that I was using because we merged it down. There's no reason to keep it anymore. So as a recap, in this case study, we were able to use Synapse and Yara grid to quickly bulk ingest rules. We bulk ingested all 169 of the FireEye rules. We were able to use those to scan our environment for malicious activity. That let us find a detection gap that we had, which we were then able to write a rule for and deploy that rule to help remediate that gap. We were able to fuse the rules and associated matches with other data that we modeled within Synapse, as well as to leverage power-up services such as VirusTotal and automation to help us perform comprehensive analysis at scale. And we did all of this while keeping our workflow entirely within a single system. So that concludes our webinar for today. Thank you for joining Rayne, Erica, and I.